हाय एवरीवन। हम लोग जेई एडवांस्ड 2025 पेपर 1 सॉल्व कर रहे हैं। ये क्वेश्चन नंबर 3 है। इसमें हमें एक फंक्शन दी हुई है जो कि पीस वाइज डिफाइंड है। फॉर एक्स नॉट इक्वल टू 0 इट्स डिफाइंड लाइक दिस। फॉर एक्स इक्वल टू 0 इट्स डिफाइंड एज 2। अब हमें 4 ऑप्शंस दिए गए हैं। ऑप्शन ए, एफ इज़ नॉट डिफरेंशिएबल एट 0. Option B is there is some positive number delta such that f is decreasing on the interval 0 to delta. Option C is for all positive number delta greater than 0, f is not increasing on minus delta to 0. And D is x equal to 0, 0 is a local minima of this function. Okay, so before deciding which option to go for, we will make some observations. So let's calculate. First of all, let's calculate its derivative at 0. So you'll be using a definition of derivative at 0 as fx minus f of 0 upon x, limit x tending to 0. So after substituting the values, we get this expression. The 2 and 2 cancel out, and since x is not 0 when we are calculating the limit, we can cancel out the x from numerator and denominator. So we are left with this expression, minus of x into 2 plus sine of 1 upon x. Now this expression is always positive because sine 1 upon x will always be between minus 1 and 1. So 2 plus sine of 1 upon x will always be greater than or equal to 1. So this expression is positive, but it lies within 1 and 3. This is a finite expression. It will never increase beyond 3. The x here can go to 0. So this product of these two expressions can go to 0 because this stays finite and this x goes to 0. The limit of the whole expression is 0. So we get that the derivative of f at 0 is 0. Now let's calculate the derivative of f for x not equal to 0. There we can simply differentiate as usual because we don't have to, all these expressions, all these quantities are defined for x not equal to 0. Sine of 1 upon x is defined for all x not equal to 0. There is no problem in differentiating this expression when x is not equal to 0. So when we differentiate, we get this expression, minus of 2x into 2 plus sine of 1 by x plus cos of 1 by x. We denote this expression as hx. Again, this expression in bracket stays finite for all x not equal to 0, and this expression goes to 0. So our first observation is that hx goes to 0 as x goes to 0. The graph of cos 1 by x is something like this. It stays within 1 and minus 1, but it keeps oscillating between 1 and minus 1, and it attains the values 1 and minus 1 infinitely many times as x goes to 0 in both directions. So as x goes to 0, cos of 1 by x will attain the values 1 and minus 1 infinitely many times. But hx goes to 0, so there will be an interval within which hx is less than 1. Okay. Within this interval hx will be less than 1. This whole expression will become positive and also negative. When cos of 1 by x is minus 1, then this whole expression will become negative within this interval where hx is less than 1. And when cos of 1 by x equals 1, this whole expression will become positive. So we see that for some delta, for some interval, the derivative does not stay either positive or negative. So it is the function f is neither increasing nor decreasing within some delta here. So from this first observation, option A is ruled out. And since we have found that for some interval here, this is delta, this is minus delta, and this is the 0. In this interval, the function is neither increasing nor decreasing, so it cannot be decreasing on any interval 0 to delta. Similarly, for some delta on this interval minus delta to 0, the function f is neither increasing nor decreasing. So on this interval minus delta to 0, the function f is not an increasing. It is neither increasing nor decreasing, so it is not an increasing function. So B goes out, C is correct, and we can also rule out this x equal to 0 is a local minima. Why? Because local minima implies that in the neighborhood of 0, here the function should be increasing and here it should be decreasing, but we already saw that it is neither increasing nor decreasing, so x equal to 0 is not also an option. So this was the solution of question number 3, and now we will move on to the next question.